Welcome to the class for partial differential equation. In this section, we'll be learning how to form a partial differential equation and how to solve few type of partial differential equation. So you know about, I think you all of you know about what is a partial derivative. So you can find out a partial derivative for some function uh, with more than two variables, well, two or more than two variables. So we'll be dealing with these things. I will go through the basics also. So let's go through a few terms which I think you already know, but I will try to do it again so that you you become more confident in this topic. So the topic for partial differential equation is very much mechanical one. So you don't have lots of things to remember or understand. You already know actually. That's why I'm saying you don't need to understand lots of things. So you already know the things. Just we have to organize what you already know to study this part of the syllabus. Okay. So let's go for the basics. First two things which is very important here is variables. Okay, there are two kind of variable. Number one, independent variable. Independent variable. Number two, the dependent variable. Okay. So what are independent and dependent variable? So if you have a function of one variable, say y equal to x cube plus x square plus 2x minus 3. So in this case, you see that value of y depends on x. So this x is the what? Independent variable and y is the dependent variable. Okay, this is the thing. Now if you have some function z such that x square plus y square, so you see that this is the dependent variable and these two are independent variables. So we have two independent variables in this equation and you have only one independent variable in this equation. So this is called a function of what? One variable. This is function of one variable. Okay, and this is a function of two variables. Okay, similarly this is thing. So when we take derivative, normal derivative is taken, you know that, we know. So this is a fact, we know that derivative is taken with respect to the independent variable. Sorry, not the independent variable. So this is the thing. So this thing is, we know. So if you have y equal to x squared plus 2x minus 3, so if you have to talk about derivative, you have to find out derivative of y with respect to x. Now in this case, you have z is the independent variable. You have two variables here, so we cannot talk about derivative in this case. So we talk about what? Partial derivative in this case. Okay, so whenever there is more than one independent variable, like a b l e, right? Variable. We find partial order derivative. Partial derivative, sorry. Okay, this is the thing. So what is partial derivative? For example, you have a function z with respect of x and y. Whenever you take partial derivative with respect to x, the y will be a constant, and whenever you take partial derivative with respect to y, x will be constant. That's it. Okay. So in this, if you differentiate this, DIFF, differentiating to partially with respect to x, so we get, so what we'll get? We'll get what? We write del z by del x. So this will be what? We are differentiating with respect to x, so x will be the variable, y will be constant. So the differentiation of x squared, the normal derivative of x squared is 2x, so this will be 2x plus differentiation of y square. But y square, when we are differentiating with respect to x, y square is what? A constant. So this will be 0. Similarly, if you differentiate with respect to y, we will write del z by del y. So this will be what? 0 plus 2y. Now let us review something. Let this y is equal to 2x square plus 3 to the power 3. So if you have to differentiate this with respect to y, so you have to find what? Find dy by dx. So can you try it? Or you can pause this video and try yourself, or you can continue watching this. So you see what is this? So this is done by something called chain rule. Okay, so chain rule is very important in this part, in this topic. Okay, we will be using chain rule too much. Okay, so if you differentiate this, so what we'll do is, actually this is dy by dx, so we're differentiating with respect to x, so this will be d by dx of this thing, right? Twice x square plus 3 cube. Okay, so this is basically what? D by, alright, d 2x square plus 3 2x square plus 3 power 3 and d by dx of what? 2x cube plus 3. So this is the chain rule. Okay, this is the chain rule. Okay, so this is like, you had a formula like this. So dy by, sorry, chat. So you have dy by, sorry, so like this. So this is the thing, this is the formula, this is the chain rule. D by dx of f of gx is d by dgx of f gx and dgx by dx. Okay, this is the chain rule. You can review it from your class 12, or I think you all of you know. So what you do is, so you differentiate this thing. So this will be like, this thing will be considered as a variable first. So you take this thing as a variable. So this became a variable. Now this part is same as this part. So this is simply d by dx of x cubed. So you just do that. So this will be what? 3 2x square plus 3 to the power 2. So d by dx of x cubed is this, multiplied by, so differentiation of 2x cubed is 6x square plus differentiation of 3 is 0. So this is the thing. So you just accumulate the things and we can go for it. Okay. So this is the basic thing. So I request you to go through that chain rule. Okay. So important thing is chain rule. Okay. Sorry. So you have to know chain rule to do this part of the syllabus. So chain rule is very important. Okay. So after chain rule, next thing which I would like you to know is this. Go through that definition of order and what order, and you have one more thing, right, of a differential equation, that's degree. So you should know what is the degree and order and degree of ODE. Okay. So this thing, if you know, ODE means ordinary differential equation. So this will be similar to the PDE also. So it will not be a big problem. So the main part is that you have to know the chain rule. Okay. If you know the chain rule and know how to find a derivative of a single variable function, it is very easy to do partial or a differentiation. Okay. So you may have 3 variables also. So when a function or when an equation is given, so one have to always remember that there is only there can be more than sorry, yeah, that's not the thing. So yes, there can be more than one dependent variable. Okay, there can be more than 2 independent variables. So that is number of dependent variable and independent variable will be variables. Okay, so whatever it is, so when we write actually dependent variable z, if I write z equal to fxy, so we are saying that z is dependent on xy. Okay, so when that means what, inside z you have x and y. Okay, so for explicit formula, if I say x squared plus y, okay, so x is independent, so you can put the value of x as 1. Y is independent, you can put the value x equal to 1, y equal to 2. Okay, but for z, what happens? To get a value of z, you have to have the value of x and y. So it is like this. Z is some quantity inside which some part is x and some part is y. So it is like this. So dependent variable are like this. Okay. So it look like a single property, a single quantity, but it is not a single quantity. It have consequence. Okay. So likewise, so you may have some, for example, a equation like u plus v equal to xy square plus 3x 3y square x. Okay, x cube. So if I have given like this, and we're saying that, and with the statement that u and v are dependent variable and the variables of x and y. So we are saying that x and y are independent variable and u and v are dependent variable. This means what? Our u is something like this. U will be some part is x, some part is y. So y will v will be this is u and this is v. V here it will be x and this y. Okay, so like this. So why I'm saying this is that, you see, whenever you have x cube, when you differentiate x cube with respect to x, what you get? So you get with respect to x and differentiating, you're getting it x 3x squared. Now if you differentiate this same x cube with respect to y, so you get 0. So why is this? You see, in this quantity you have x, you are differentiating with respect to x, therefore you are not getting a 0 here. So here you see you have x cube, you don't have y here, so you are differentiating with respect to y, you are getting a 0 here. Now you see z, in z you have x and y, so therefore when you differentiate z with respect to x, this this quantity, this is a quantity actually. This is not equal to 0. You cannot put like differentiating this thing with respect to x. So you cannot have, for example, if you differentiate this with respect to x, this equation, okay, so I'll write it here. So z equal to x squared plus y. So differentiating this with respect to x, you'll not get del. This will be actually del z by del x equal to del x squared by del x plus del y by del x. So it is not like this quantity will be 0. Okay, so this is what 2x, and this is what, this is del y by del z. So you're differentiating y with respect to x. Y is a constant here, it is an independent variable, it is 0. So this part is not equal to 0, so this will be wrong. Okay, why? Because inside z there is x. So actually we don't know what is the quantity of x inside z, but we know that it is a dependent variable, there will be x. So when there is a x, when you differentiate with respect to x, it cannot be 0. Okay, so that is the point. So therefore this quantity is not equal to 0. This is what, del z by del x. So therefore we write del z by del x. Okay, this is equal to 2x. Okay, this is the main part. Okay, whenever you differentiate a independent variable with respect to dependent variable with respect to independent variable, so this quantity is not equal to 0. So I have seen this, that actually I have seen that lots of students differentiate this type of equation. Okay, for example, this z equal to xy plus y cube plus 3x squared. So if you differentiate this, differentiate partially with respect to x, so what you students does is, it will differentiate z with respect to x, so it will write 0 here, he will write 0, differentiate with respect to x, so y is constant, so this will be y, differentiation of x is 1, so differentiation of y cube is 0, so plus differentiation of this part is 6x. Okay, this is a common mistake. This type of thing is a common mistake. Okay, so this should not be there because inside z you have both x and y. Therefore, this is not equal to 0. This will be what, del z by del x. So this will be basically the correct statement should be this one. Okay, so this is the correct statement. So with this, I think I am ready to continue with the partial differential equation, because I think okay, so now you already know what is a dependent and independent variable, so we can start with differential equation. Okay, so partial differential equation. So what we'll do is this, you see. So first of all, you see what is a partial differential equation. So an equation containing one or more partial derivative of unknown function of two or more independent variables is known as partial differential equation. That's it. Okay, we don't this is like differential equation only. In an equation, if you have a partial derivative, we call it partial differential equation. That's all. Okay, so here you see this is the definition. These are few examples. You see del z by del z by del x, del z by del y. These are partial derivative of z with respect to x, partial derivative of z with respect to y is equal to z plus xy. So this is a dependent variable here. So this is also a differential equation. This is a differential equation. Okay. So whenever you differentiate there's a variable once, we call it what? First order differential partial derivative. If you differentiate 2 times, we call it second order partial derivative. You see this quantity. Okay, in this quantity what we have done is we have differentiated z with respect to x1. So this is a first order partial derivative of z. This is the first order partial derivative of z with respect to y. And this is also first order partial derivative of z with respect to x. Okay, so this is what we have differentiated this z with respect to y 3 times. So this is a third order partial derivative. This is a first order partial derivative. Similarly, you can just go on and see that this is a second order partial derivative and this is a first order partial derivative, like this. This is a first order partial derivative. Like that of ordinary differential equation, you have an order of partial differential equation. Okay. So what is the order of partial differential equation? This is very this definition will be important for you for examination purpose also. So what is the order? Order of a partial differential equation is defined to be the order of highest partial derivative occurring in the partial differential equation. So if a partial differential equation is given to you, so you see what is the highest order of partial derivative in the equation. Now after that, when you see the highest order of partial differential equation, then you see what is the degree of that, highest degree of that term. Okay, so that will be order of partial differential equation. Okay, you see in this equation you have a first order partial derivative. This is a first order partial derivative. The order of this is 1. So the degree of this is 1. The degree of this is 1. So what is the maximum degree of first order derivative present in this equation? 1. So the order of this differential equation will be 1. So you see this is the first order partial derivative. Order is 2. Degree is 2. Power is 2. So this is the third order partial derivative, and this is the first order partial derivative. First you see that what is the highest order of partial derivative present in this equation? 3. So this term. Okay. Now what is the degree of this? So therefore, what will be the order of this differential equation? This PD 3. Highest order partial derivative present in this differential equation is 3. So therefore, degree order is 3. Now what is degree of partial differential equation? Degree is the what? Highest power of the highest order partial derivative. So here you see the power of this. This is the first order partial derivative in the equation. The degree power of this is 2. This is the third order partial derivative of derivative. The degree is 1. So what is the degree of a partial derivative equation? This is the highest power of the highest order derivative. So you see, first if you have to find out degree and order of a partial differential equation, first of all you see try to find out what is the highest order partial derivative in the equation. So that will be what? Order of the differential equation. And what is the degree of that? What is the power of that? That will be the degree of the differential equation. So this is a order 1 degree 1 partial differential equation. This is the order 3 degree 1 partial differential equation, because power of this term is 1. This is what? Here this is a first order derivative. So power of this is 1, power of this is 1. So therefore what is a first order partial derivative and degree is 1. Here also you see with respect to x, with respect to y, with respect to z, we are differentiating. So here u is the independent variable, x, y, z are independent variable. So you can see you have only first order partial derivatives here. So the order of this differential equation will be 1. And what will be degree? You see degree of this term is 1, degree of this term is 1, degree of this term is 1. So therefore degree will be 1 only, because maximum degree is 1. So you say here this is not partial. Now you cannot find out degree of this equation directly, first because you have to square it. So you square this differential equation first. After that you find out the degree. So you see this is the first order derivative, second order derivative is the first order derivative. So first thing is clear, this is a second order differential equation. Now squaring this both sides, so you'll get that the degree of this equation will be 2. So similarly you try to find out the degree of this degree and order of this equation. You can just see that there are only first order partial derivative. This one is a first order partial derivative, first order partial derivative, this is a first order partial derivative. The power of this is 1, power of this is 2, power of this one is 2. So what is the maximum power of the first order derivative present in the equation? So you can just see that it is what? 2. So therefore the degree of this partial derivative PDE is 2. So these are the formal definitions. You can just go through it and try to write it down and make a note for yourself. Okay, next, linear and non-linear PDE. What is a linear PDE? Any partial differential equation is said to be linear if the dependent variable and its partial derivative occur only in first degree and are not multiplied. Partial differential equation which is not linear is called a non-linear partial differential equation. Means what? If you have only the degree of each partial derivative is 1 and they are not in multiples, means you don't have terms like del z by del x into x into del z by del y. This type of things are not there. Means order is 1 and degree is 1. When you have order and degree both are 1 in a partial differential equation, with that there is no multiple of thing of dependent variable, then this is called what? Partial differential equation, linear partial differential equation. So that is the thing. So here we have linear means degree should be 1 and order of the differential equation should be 1 and degree should be 1, and the independent variable, the degree of independent variable present in the differential equation, that should be also 1. Okay, so that is the thing. If equation is not linear, we call it non-linear. So you can just see from this example that which of the following are linear. Okay, so what are the non-linear? So you try to see, and we'll get back to this later on whenever we start solving partial differential equation. Okay, so these notations are very important. So whenever you have a dependent variable z with two independent variables x and y, okay, so what happened? These are a notation. Del z by del x is denoted by small p, del z by del y is denoted by q, differentiation of z with respect to x 2 times is denoted by second order differential equation, partial derivative of z with respect to x is denoted by r, and with respect, if you are differentiating a dependent variable with respect to x and y 2 times. Okay, so we differentiate this thing with respect to x, again we differentiate with respect to y. So we denote the term as what? S, and t is the second order partial derivative of z with respect to y. So whenever you have n number of independent variables, say x1, x2, xn, and z is a dependent variable, then we differentiate. We start with p1. P1 is a differentiation of z with respect to x1, and with respect to x2, when you differentiate z, it is called p2, and like this. Okay. Now, if you have independent variables, so we can also write this notation also. This is what? Ux. So ux means what? Partially differentiating u with respect to x, partially differentiating u with respect to y is uy. Okay, with suffix. Okay, suffix denotes the variable with respect to which we are differentiating partially. Okay. So this is very nice actually. Okay, so this notation, this is x. So ux means what? We are partially differentiating u with respect to x, again with respect to x. Uxy means we are differentiating with respect to x, y, then with respect to x. Okay, like this, and so on. You can have notation uyx, yxy. So they are mostly they are same, but in some cases they are different. But in our course, this will be same. Uxx will be uxy will be equal to yx. Okay. Now you will have uxxx, uxyx like this. Okay. So now there is first thing. So classification. Okay. So what is a linear partial differential equation? A first order equation of this type: f x y p q. If you have an equation with this much variables x, y, z, p and q equal to 0, if you have an equation of this form, this is known as what? Linear differential equation on what? P, q and z. So this should be linear. P, q, z, the power should be what? 1. Then we call it what? Linear differential equation, and you don't have what? Multiples of them also. On a p, this means what? You don't have a term like pq, qz, pz in the equation. Okay. So partial differential equation, this linear partial differential equation can be written like this. You have a function capital P x y and small p plus capital Q x y q plus r x y z plus x x s x y. So here p x y, q x y, r x y, s x y, these are what? Functions of what? X and y. So for example, if you have an equation like this, you know what is p? P is what? Del z by del x. Q is del z by del y. So you say here you see this is the first order partial derivative of x, this is the first order partial derivative of this is the first order partial derivative with respect to x of z, this is the first order partial derivative of z with respect to y, and here z square. So you see the degree of this p, q and z is 1. So this is a first order this is a linear differential equation, linear partial differential equation, and you can see here this the term with p is what, only function of x and y. This is what, y x squared. You don't have a z and q here, you don't have a z and q p and z here, you don't have a p and q here, so with respect with z, okay, and you have a term here which does not contain p, q and z, okay. So you see pxy is what, x y x square. What is px qxy? Qxy will be what, the term which is with the coefficient of q actually. So coefficient of q is what, x y square, coefficient of z is what, xy, so this will be rxy, and this term is what, sxy. So always equation of this form is called what, a linear partial differential equation. Okay, so this is also a linear partial differential equation. You can see that p, the degree of p, q and z are 1. So what is p, capital pxy here, 1, capital qxy will be 1, capital rxy will be 1 in this equation. So these are the partial differential equation. So you have also something called semi-linear equation. So in semi-linear equation, what happens? This is a first order partial differential equation. The first order, it should be first order, and it will be a semi-linear equation if it is linear in p and q, and coefficient of p and q are functions of x, y only, and if it is given by the equation of this form. Means it is linear in p and q, but in case of z it may not be linear. Okay, so z will be there. Okay, so means general equation of this form is called semi-linear. This pxy means coefficient of p should be a function of x and y, coefficient of q should be a function of x and y, but other term there may be z, x, y, z. So means you can have the power of z more than 1. So that will be what, semi-linear. So this is a semi-linear differential equation. You see coefficient of p is x, y, the coefficient of q is x square, y. So this part is linear, but here z square. So it is where it is z square. So therefore this is not linear. This is what, semi-linear. Okay. So you can just see you have something called quasi-linear also. What is a quasi-linear differential equation? So they are what, linear in p and q. So linear in p and q, but this coefficient will be functions of p, q and z, and coefficient of everything here we don't care about this z. Okay, so whenever you have z as a coefficient of p and q, so we call this would be q actually. So that will be what, quasi-linear partial differential equation. And non-linear means what, a partial differential equation where which does not come under above equations. Okay, if above equation, if it is not linear, not quasi-linear, not semi-linear, we call it what, non-linear partial differential equation. Okay, so this is what about the partial differential equation, the beginning. So we'll, in the next class onwards, we'll be starting with the formation of partial differential equation. After that, we'll start solution of partial differential equation. So in this class, basically we have learned what is the order of partial differential equation, what is the degree of partial differential equation. So what are the important things? So for the next class, I would like you to at least go through the chain rule, okay, and try to go through the basic formulas of their derivatives. So I think you already know it, but actually just brush up, you just go through the formulas and you come to the next class prepared. So I will be uploading the next class very soon. Okay, thank you.